Hey, today we're going to talk about 9.2, reducing ozone depletion. So take a moment, check out the enduring understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So in 1987, there was a multinational agreement called the Montreal Protocol. And that Montreal Protocol agreed to phase out CFCs, the chlorofluorocarbons. You'll see down here, this is the ozone hole in 1979, or the ozone layer, and this is really thin. This is 1987, 2006, 2011. Now, it looks like it's getting worse. Well, let me explain. But what the goal was to phase out the CFCs and then replace them with what is called HCFCs, and then replace that with HFCs. And I will go over the chemistry right now. So a CFC, remember that it has very high ozone destruction potential. It stays in the atmosphere for a very long time. And 50 to 100 years for one of these chlorine atoms. One of the chlorine atoms that can be removed, it can break apart ozone for 50 to 100 years. This also is a greenhouse gas with a very high warming potential because it has such a long lifespan. So one of the goals of the Montreal Protocol was to phase these out and replace them with HCFCs. And it's basically a CFC, but it's got a hydrogen. So it's a methane, which this was a methane base as well, but this is methane. This is only going to have one chlorine that can be broken off, so there is some destruction potential, but not as high as CFCs. It still has the same high warming potential because this does still have a longer lifespan. It has a longer residence time in the atmosphere. And developed countries phase these out by 2020. That was part of the agreement. And developing countries have until 2030 to phase out HCFCs. So the alternative was an HFC. There is no chlorine, so it doesn't have any ozone destruction potential. Fluorine doesn't do the same thing as chlorine up in the stratosphere. It still is a greenhouse gas, however, so it has a very high warming potential, and that is still technically a problem for climate change. So to combat that, the ultimate goal is to phase out this entirely and to switch to HFOs. Don't even ask me what the HFO stands for. I don't remember. You don't have to know. However, what you should know, you don't even have to know the chemistry. But notice there's 3 carbons, there's 4 fluorines, and 2 hydrogens. This is a double bond in here between these 2 carbons. Okay? If you're a chemistry geek and you want to know that, great. It's not required at all. It doesn't have any ozone destruction potential, and it has a very low warming potential because the lifespan is not as long in the atmosphere. So these molecules do not stay around as long as the CFCs. Okay, so this is a little graph that kind of shows over time what's been happening. So this is like around the time, in the 80s and the 70s when we were using CFCs. The CFC use was still pretty high, and the ozone layer was gradually decreasing. Now, once we stop CFC use or greatly limit CFC use through the Montreal Protocol, the amount of use of CFC decreased. However, we still saw depletion of the ozone layer, so this continued to happen. It wasn't until much later, like even in 2011, it started to now has since rebounded, and it will continue to rebound because we have stopped the use of these ozone depleting products. But remember that this chlorine can stay active in the atmosphere for a very long time. Sorry, up in the stratosphere to be specific. It could stay active in the stratosphere for a long time, and that's why there is this lag time between stopping the CFC use and the ozone layer recovering. So to practice for the FRQ, I would like you to explain how the Montreal Protocol reduced ozone depletion. So I hope that this video was informative. I thank you for your attention. I will see you soon.